Hello students. So we'll just start with the next lecture part. Okay. So in last class we have discussed introduction to design, which was fully theoretical part, which consists of 5 marks. That is, we have discussed what is machine design, introduction, just introduction things. That is what is design. Okay. Then types of design, that is adaptive design, development design, new design. Okay, rational design. All those things we have studied. Then we have studied a few design considerations like load. What do you mean by load? What is stress? So stress is given by what formula? Then strain means what? Change in length to the original length, ratio of change in length to the original length, or increase in length to the original length, that we have studied. So then we have gone through stress strain diagram. So that is stress strain diagram when you are applying any component, that is when you are applying any load on a component using UTM, universal testing machine. Then what the graph you are getting for mild steel, what you are getting, we have elaborately studied that. What do you mean by proportional limit, Hooke's law, then what is elastic limit, what is ultimate stress, that is ultimate strength of a material. Then we have studied breaking point. So then after that we have studied factor of safety. So FOS, factor of safety, means what? So it is just the ratio of ultimate stress by working stress. So if you just divide, factor of safety you will get. So if more the factor of safety, that value, whatever you are getting, that value, if it is more, that means the whatever component, the stress whatever you are applying on a component is more it is safe. Okay, that it is the factor of safety gives the gives the value of safety of a component under loading condition. So that is what we have discussed, and a few factors, what are the factors on which that factor of safety depends, that we have studied. So then we have studied different theories of failure. So that is principal, maximum principal stress theory, maximum strain theory. Like that we have studied around 5 types of theories of failure. Okay, so these are very important theory part which we have covered in your first chapter, that is machine design. So in the next chapter, that is you are having shaft and keys. So the chapter is okay, the chapter is shaft and keys. Okay, so in this chapter what all we are studying, it consists of two parts. One is shaft we are studying, then we are studying keys. So in this whole chapter, so what all we are studying, we are studying what is the definition of a shaft, different types of shaft, what are the materials used in shaft, standard sizes of a shaft, then design of a shaft, and problems on shaft. So here it consists of 5 marks theory and 15 marks, one problem will come. So one problem and one theory will come. So in this part of a lecture we are covering the theory part, theoretical part. Okay, theoretical part about shaft we are covering. Then in from next class onwards we will be taking problem on shafts. Okay, so we'll just start with the shaft. So what do you mean by a shaft? So shaft is a rotating machine element. So shaft is nothing but a rotating machine element. It is a rotating machine element which is used to transmit power from one point to one place to another place. So it is, so shaft will be like this. So you are having a shaft, so it will be rotating. So it will be a rotating machine element, so which is used, see, if you want to transmit power from this point to this point, so then you are using a shaft. So shaft is a rotating machine element which is used to transmit power. The main work of a shaft is to transmit power from one point or one place to another place, is nothing but a shaft. Okay, now we'll study what are the different types of shaft. Okay, so that is different types of shaft. There are two types of shaft mainly. One is transmission shaft, one is machine shaft. So what do you mean by transmission shaft is, as I explained, a shaft which which is used to transmit power. Okay, if you are using that shaft for power transmission between source and machine from one place to another place, then it is called as transmission shaft. So transmission is mainly it is used for power transmission. If you are using it for power, so power transmission from one point to another point, then it is called as transmission shaft. Okay, whereas machine shaft, so next type is machine shaft. These are used in a machine, so these are the integral part of a machine. Okay, if you are using those in a part of a machine, in an integral part of a machine, then such type of shaft are known as machine shaft. Okay, so shaft is a rotating element which is used to transmit power from one point to another point, is called as, okay, is called as a shaft. So if you are using that shaft, if you are using that shaft for machine, okay, for transmission of power, then it is called transmission shaft. If you are using that as an integral part of a machine, then it is called as machine shaft. Okay, these are the two types of shaft. So we have just covered what is shaft and different types of shaft. Okay, so suppose if I take an example, this as an example. Okay, so it is having from this place to this place, it is used to transmit the power, then it is called transmission shaft. Okay, in a machine, if you are using it, it is called as an machine shaft. Okay, by the word itself you will understand that if it is using for transmission of power, if it is used in machine. Okay, so these are the different types of shaft. Okay, now we'll see, so what are the materials used. Okay, suppose if you are designing a shaft and you are using a material, so that material, which type of material, what should be the property of that material, whatever you are using in a shaft, that we will study. See, when you are using a machine, okay, shaft in a machine or for a power transmission, so first quality of that material should be, it should have a high strength. So it should be high strength. So as you have studied factor of safety and all, that is ultimate strength. See, for mild steel, so whatever ultimate strength, that is maximum it can hold up to 400. So that means like if you are using this, okay, more, that is ultimate strength more, so it is nothing but high strength. If you are using it more, that means you can work more efficiently. So that is why, so it should have a high strength and it should have a good machinability. Why it is used machinability is nothing but the ability of a material to undergo a few machining operations. That is, you can just machine it and you can give any shape and size, that it should have a good machinability. Because those are, see, if you see the shaft, it is having a circular, okay, circular area here it is having a circular. If you just take like this, if you just view in a 3D, so it will be like this. So it is having a circular area, so it should have a good machinability. So that is good machinability it should have, and it should have a good heat treatment properties, that is hardness and all. It should have a hard material. It should be from outside, it should be hard material, and it should be wear rigid. So it should not have a wear and tear by small okay forces, small this thing, it should not lose its upper material. This material it should not lose, that is wear and tear. So it should not break easily, that is high strength. It should not, it should be machinable. It should have a high wear and tear, okay, resistant to wear and tear. It should not wear and tear easily. Okay, it should not lose this material, upper side of a material. So that is nothing but it should not have a, so it should have a high wear and wear resistant property. So these are the different materials, whatever you are using in a shaft, these should have these four properties. So it should have these four properties. Now we will see the design of shaft. See, design of shaft is very important. See, what we are studying is here how we are designing a shaft. If you are taking a shaft and if suppose if you are working in some industry, So there, if you are getting a shaft, okay, the design of a shaft, how you are doing that basic things we are studying here. So design of shaft, it is mainly based on two types. Okay, if you are designing, so shaft may be designed on the basis of strength or on the basis of rigidity or stiffness. Okay, here we are studying how the method is there, how to design a shaft. That method we are studying. See, for that you are having two methods. Okay, so that is, you are having two methods. That is, one is strength method, one is rigidity method. So in this I will just try to explain that. So in your problems, what it will be given is, see, in your problem it will be given, see, it will be given power will be given, okay, and rpm will be given. That is, if a shaft is there, so if it is rotating like this, okay, if it is rotating, so if it is rotating like this, so at what rpm it is rotating? That is, for example, 200 rpm, revolution per minute, rpm. So how much revolution it is making, and how much power it is transmitting? Suppose if it is transmitting 20 kilowatt, kilowatt is for used for, so kilowatt is used for transmitting the power. If these two are given, so always in all the problems it will be given. For this you have to design a shaft. For this you have to design a shaft, and one more thing will be given, the stress will be given. So what I mean by this symbol is toe. Okay, toe is nothing but a shear stress. So shear stress, suppose if it is given 400 megapascal. Okay, 400 megapascal. So briefly we'll study what is this. Okay, that is, so what is this? So we'll just see. Now, first step what you have to do is torque you have to find. For finding out torque, so you are having direct formula. See, as I told, you are having the formulas on the data handbook. So that is in the page number 50. So all these formulas are there. So using these all formulas, you need to design a shaft. Okay, now first thing what you have to do is, you have to find what is the torque. So torque is given by, so it is given by this formula. That is, it is in the 3.3a. you are having this formula. That is, I'll just read. Torque is equal to, T is equal to 9.55 into 10 raised to 6 p. What is p? P is given here. So this p you have to substitute it. So p you have to substitute into 9.55 into 10 raised to 6 into p. This p value is 20 kilowatt is there. So you just substitute 20 divided by n. So n is nothing but rpm. rpm is given how much? 200. So using this, you can easily find out what is the torque. So after finding out torque, next, so it is two methods are there. One is strength method. So I have told that is, you can design a shaft using strength method and rigidity method. So one is the strength method we are discussing here. That is first part. So we are discussing here strength, and this part whatever is the remaining is based on rigidity. These are the two methods. This is first method and this is second method. So now in first method, strength, based on strength, so you are using toe. Toe is nothing but what I have told. So it is shear stress. So it is given 400. Now shear stress is given by 16t by pi dq. So it is there in 3.1, which is in same page, that is page number 50. So in page number 50 you are having all this formula. That is, this is for solid shaft. Okay, and for hollow shaft is also one formula is there. Just you need to remember this formula. So shear stress is how much it is given? 400 is there. So if you just substitute 400 here, and if you just substitute T, what is T? T you are getting here. This T, if you just substitute, you will get D. Pi value is 3.142. Shear stress is 400. T whatever you are getting from here, if you just substitute, you will get diameter. This is for solid shaft. What do you mean by solid shaft and hollow shaft? If you are just taking this example, as I explained here, you just take this example. See, this is solid shaft. If I just draw a hollow shaft here, it will look like this. So this will be a hollow shaft. See, you are having a material here. So here material is there, okay, and here you are having a hole. So here this thing is there. Here you are having a hole. So it is called as a hollow shaft. So how many dies? See, here you are having only D. Here you are having outside D is D naught, outside diameter, and this whatever you are having here. So in this part you are having Di. So that is inside diameter. So you are having two diameters, that is this will be D naught outside and this will be Di inside diameter. So you are having two diameter. For this it is given, this formula is given for hollow shaft. Same 16T by pi D. D is there, D naught you have to put and divide into 1 divided by 1 minus k raised to 4. Okay, this formula you have to remember. Just these two formulas you have to remember for strength. Okay, for strength you have to remember these two. Directly they are there in the data handbook, just you need to use. See, when we solve one or two problems, you will easily understand this. Just for the purpose of learning, you just try to understand, but when you solve two or three problems, you will easily understand. Now based on rigidity, it is theta is equal to angular deformation. Theta is equal to 584 into T. What is T? T will be this torque and length will be given. In this type of problems, all these values will be given. Okay, so L is length. So what is the, suppose if you are taking a shaft, what is the length? So what is the length of this? So that is length divided by G. G is modulus of rigidity. That value, it is constant. Okay, that value will be given and D you have to find. Theta will be given, T will be given, L will be given, G will be given. You have to find what is diameter. So in this whole this thing, so similarly same thing. So same 584 T into L into G D naught raised to 4 divided into 1 divided by 1 minus K raised to 4. So these four formulas you are using to design. See, when we say design, what you are doing is, so all the values will be given. You have to find what is the diameter. So if what is the diameter you have to find. So that is, if it is solid shaft, you have to use this formula. If it is hollow shaft, you have to use this formula. And based on rigidity, if it is given, all these values will be given. That is theta will be given, L will be given, G will be given. You have to find what is the diameter. So don't get confused. It is very easy. So when we solve two or three problems on these formulas, you will easily understand. Now what is your work is, you have to take data handbook. So that is, I have told already, design data handbook. See, because without design data handbook, it is impossible to solve these problems. So see here, if you just see, so in this whole chapter we are using all these formulas. So whatever problems formulas we have discussed, we will use all these formulas for solving these problems. Okay, you need data handbook. See here, I am saying, see, you are using page number 50 and using equation 3.3a, 3.1, 3.1. So you will not understand that. So by seeing the data handbook, then only you will understand. For that, what you have to do is, you have to take data handbook. Data handbook is K. Mahadevan and Balveer Reddy. I am saying it again and again because you just take this data handbook and just try to see the video and try to work on your own. So when I say page number 50, you open that and see that equation, then only you will understand. So otherwise it is very hard to understand. So from next class we will just take problems on this. For the whole unit, in this whole unit we are using these many formulas, four formulas we are using. See, in shaft only it is given around 25 to 50 problems. So around 25 to 30 formula. So you should know which formula to use. See, I am saying in page number 50 only all these four formulas are there. So you have to use those four formulas and solve the problem. So this will be the design of shaft. So and this will be the design of shaft. So in this whole chapter, what all we have studied the what is shaft, different types, that is transmission shaft and machine shaft, and which the material whatever you are using, what should be the property of those material we have studied. Then we just briefly discussed the whatever the formulas you are using for design of shaft we have studied. In next class, when we are using data handbook, we will study this standard sizes, and then we will solve few problems on a shaft. So this will cover your shaft chapter. So you are solving around many problems, will be solving around 5 to 6 problems you will solve. Then only you will understand the concept of shaft. Okay, so this part of a lecture we are studying this much. Okay. So then we'll when we go for next lecture, we'll study more things.